Here we're going to start lesson 1.6, linear equations in one variable. Okay, so let's put this down, 1.6. What we're going to do real fast here is go through some definitions and some stuff here that you just kind of need to, most of you already know, but it's always a good idea to review. So notice here, an equation, this is going to be a statement that two expressions are equal. So let's look at this. This is just literally solving something of, like, say, 3x minus 1 is equal to 2. Notice the thing you need to look for here is that it contains an equal sign. That it denotes an equation. An identity is a statement, okay, or is a statement that is always true, okay? So for this, you would see something like, say, 4 is equal to 4, okay? 0 is equal to 0, okay? You could also have some other things, but just kind of denote that both sides end up equaling each other, okay? A contradiction is a statement that is never true. So, for example, if we kind of combine these two, notice that it's going to be 4 cannot equal 0. Notice a little diagonal line through the equality symbol. That literally just means not, okay? Conditional is a statement that is only true for some values. Once again, using our example from up here, that would also be a conditional statement. Okay, notice these words, statements. Okay, notice this 3x minus 1 is equal to 2. Well, when we do the algebraic process, we can say this is only true for when x is equal to 1. Okay, it would not be true for any other value other than x. Okay. A solution set is a set of values that make an equation true. Let's once again use our 3x minus 1 here. Notice an example for this one. Okay, kind of coming over here. Notice with our 3x minus 1 is equal to 2, we'll realize that we could have the value of this. Say x, such that, that's what that little line means there, such that x is equal to 1. Okay, that would be the solution set. There's also many other ways I could have wrote this. I just tried to keep it very simple. Solution, any one element. Okay, solution, any one element. Okay, remember an element, okay, is something that is inside of a set. So if this thing only has one element, that's 1. But if it had more than one, any element inside of it. Continuing on here. Equivalent equations. Two equations that have the same solution set. For example, once again, continuing with our example above, say I had 3x minus 1 is equal to 3x minus 1. Well, realize that these would be equivalent. Now, it's not always going to be that way in this class. You may have something that looks really weird on this side, really weird on this side, but once we get done solving, they would have the same solution. So let's continue on. Linear equations in one variable. A linear equation in one variable, say the variable x, is an equation that can be transformed into the form of ax plus b is equal to 0. Realize that there's an x value here with a power of 1, which we don't show that, but that lets us know automatically that we're dealing with a linear. Where a and b are real numbers and a cannot equal 0. Okay, because anything times 0 is just 0. And then, in that case, you would have an untrue statement here. Such equations are also called first degree equations. Notice that's why I put that 1 there, as x appears to the first power. Continuing on, I'm going to do one of these, and then the other two I will leave for you for your notes. And then we're going to decide what they are. So notice, let's work out this first one here. Looking at this very carefully, I've got expressions happening on both sides here. So let's just start doing the algebra that we know how to do and start slowly but surely working this out. On the left-hand side here, I'm going to go ahead and distribute here. That is going to give me 3x. Then that's going to be a negative because positive and negative make a negative. 3 times 2 is 6 plus 7x. All equal to 1. Minus, now notice minus here, this is a negative and a positive, that's going to go to what? That's just going to go to 2x there. Then notice here, this is going to go to negative. And if you're going to get, I guess, messed up anywhere, it may be right here. So if you need to, you can pull this out and realize that you have negative 2 over 1 times 1 over 2. Realize that these are going to reduce out, okay, and that is just going to leave us with a negative 1. Looking at this one right here, notice that this right here, I've got a negative 1 and a positive 1. These guys are going to cancel out. Looking over here, let's go ahead and combine like terms. Let's work in this direction here. So we're going to have what, 10x minus 6 all equal to what? Negative 2x. Realize that we're dealing with a linear here. That means we need to get all the x's to one side, and then we need to go ahead and get all the constants to another side. Really doesn't matter how you do it, okay? For this one right here, I'm going to go ahead and come in here and add 2x to both sides. Being careful here, go ahead and rewrite. Notice here I'm going to get 12x, okay, minus 6, now all equal to 0. We can go ahead and add 6 to both sides. Let's draw a little arrow so we always make sure we're working intentionally. And then we're going to get 12x is equal to 6. Divide off the 12. And then make sure you simplify. You're going to get x is equal to 6 over 12, which we know that is going to reduce into 1/2. And that would be our final answer. And realize, I'll write this in red, that since this came down to one answer where x only equals one thing, it doesn't matter if it's 1, 2, or 3 things, still we have a conditional statement. Okay, and like I said, I'll leave these other two. You can look those up in your notes or try working them out for yourself. Okay, they're actually not that hard, but I would try to ask you, try to find out what they create. Do they create conditional, a contradiction, or an identity? Okay, that'll be something you see on your homework. Solving linear absolute value equations of the form. The absolute value of ax plus b equals c means ax plus b equals c, or the negative ax plus b equals c. I'll explain what this part means here. I want you to realize that this right here, see this little form right here, which they don't really explicitly state, this is the standard form. Okay, very important to know that because you really need to get things into standard form. So let's work one that looks a little weird. Let's do this one right here. And like I said, I'll do the rest of them. Leave it for your notes. Actually, let me step back just real quick, just so I can kind of explain this statement here. I'm not going to solve it for you, but realize what this is saying here is, notice this first one here. Okay, realize an absolute value is comprised of two answers, a negative and a positive. Okay, because it denotes distance. How far away are we from 0? So notice we've got this 3x plus 2 is equal to 5. That's what this part is saying. But then we have this 3x plus 2 is equal to, well, how about, 5. Which we know that would actually be 3x plus 2 is equal to negative 5. That's literally what this side is saying right here, okay, on that next one, okay? So if you had a whole expression in here, okay? So notice then you can solve both of these and get your answer. Well, how does that work out? Well, let's look at this one right here. The first thing I want to do when dealing with this one that looks really, really weird, I don't like dealing with these fractions, so let's go ahead and reduce out the fractions by multiplying everything by 7. Okay, so I'm going to pull a 7 here and realize I'm multiplying every term by 7. Okay, I'm really going 7 times x and then 7 times 5 over 7. Sometimes you might see it where I'll put parentheses around everything. Okay, so realize here, if we had to do this, let's do it this way, I'm multiplying everything by 7. Okay, so notice whenever we rewrite this, I can get 7x plus 5. Why'd that work out? Because notice here, the 7's reduced out, is all equal to, now we've got this 7x plus 3. Now once we rewrite, we can go and say, hey, I've got an absolute value on this side. I don't really need to rewrite the absolute value on this side. It's not really necessary, but you need to keep one of them. So when I rewrite this, thinking about what I did right here, let's rewrite this again. Notice I have 7x plus 5 is all equal. Well, my positive way is going to be 7x plus 3. But then notice I rewrite it. 7x plus 5 is all equal to negative 7x plus 3. This one we can go ahead and distribute that negative, and notice we get 7x plus 5 is equal to negative 7x minus 3. It is at this point that you're going to want to go ahead and go and start solving everything. Okay, so notice on this one over here we can see that these on this side, okay, notice that the 7 and the 7, these guys cancel out, because if I subtract off 7x off both sides, they cancel out. Immediately we end up where that does not work. 5 cannot equal 3. Okay, so then we're going to come over here to this side. Well, does this side work? Well, yeah, let's take a look at it. Notice I can add 7x here, add 7x here. That cancels out there. Right here I can subtract 5 and subtract 5. Okay, so doing this very carefully, notice, let's come back in here, let's do our math. Notice 7 and 7, that's going to give me a 14x, by the way, that did cancel there, all equal to 8. That's a negative there. Let's divide off the 14 and then realize that we can go ahead and say, hey, x is equal to, we do know that these are going to reduce down to negative 4 over 7. And that right there would be our final answer for this one. Scrolling down, we can also look at some of these. Solving linear equations for one variable. Sometimes, whenever we're doing something like this, we have to look at these and go, okay, well, I may need to get to a variable in here. Okay, well, how do I do that? Well, for example, like I said, once again, I'll leave you 2 examples to do. Notice how this first one here says solve for m. We need to isolate the m, is what we're trying to do. Say they've given us everything else, but we don't know what it is. Say they've given us the velocity here. Say they've given us the kinetic energy, but we don't know what m is. This is something we need to know. Okay? Well, we can do that pretty simply. Let's look at this. Take a look at, notice we have this 2 here. It's going to rewrite. K is equal to 1/2 mv squared. Well, how about we multiply both sides, okay, by 2. Erase that. Let us multiply both sides of this equation by 2. So I'm going to come in here, multiply by 2. Over here I'll multiply by 2, realizing that this reduces out completely. So now what do we have? We have 2k is equal to, we don't need the 1 anymore, but then we have this mv squared. Well, how about we divide off the v squared off both sides. Here it reduces out. Notice I didn't say the word cancel. And now we know that m is equal to, well, what? 2k all over v squared. Now we have our m value if it's something that we needed. Okay, and so that's exactly how a question like that would work out. The rest of these I'll be solving in extra videos, so if you have any questions, feel free to email me.